Okay, so this is a practice problem for the speed of sound, and there's two main equations that we're going to be using that you can see on the top. So the first one is velocity or speed equals distance over time. The D stands for distance, and then the T stands for time up here on the left. And then the equation on the right is V sub air, which means the velocity of sound in air. There's different equations for the velocity of sound in solids and liquids, and they differentiate a bit, but in the case of this question, we're going to be using the equation for air. So the velocity of sound in air equals 331 meters per second plus 0.6 meters per second per Celsius times the temperature, which is also in Celsius. And that will be important in a minute when we start to work through our question. And our question is, a man at the bottom of the Grand Canyon yells, creating an echo that he hears 1.15 seconds later. If the air temperature is 21 degrees Celsius, how far from the man are the canyon walls? So, first off, we're going to be using this equation because we need to solve for velocity so that we can plug it in. Because we're given time within the equation, but we're not given velocity or distance, and since our last step is to solve for distance, we want to find velocity first so that we can then plug it into that equation. So, using this equation up here, the velocity of sound in air equals 331 meters per second plus 0.6 meters per second per Celsius times 21 degrees Celsius, and we're using 21 degrees Celsius because it's given to us that that's our air temperature. And having the Celsius here and the Celsius here in the denominator cancels them out, so your final units are just going to be meters per second, which makes sense because this is velocity. So when you plug those numbers into your calculator, that equals 343.6 meters per second. And we're just going to plug that into the other equation now, the one on the top left. Velocity equals distance over time, which in this case is going to be 343.6 meters per second equals distance over 1.15 seconds. And that 1.15 seconds is given to you in the question itself. And what you're going to do is you're going to multiply this 1.15 times 343.6 to get rid of it in the denominator and to isolate the distance. And because you've got seconds here and seconds here, if you were to set it up in like the picket fence model, you would see that the seconds cancel out, leaving you with just meters as your final units, which also makes sense for distance. So when you plug in those numbers, you're going to get 395.1 meters, which is going to be your final answer for distance.